So I want to show what it looks like to have my Flask app. It's actually my resume. It's a Flask app that generates a page that shows my resume. And I want to show what that looks like with that container running in my home cluster. So usually what I do is just log into the node and then have a directory where I've cloned the repo. So all this stuff is in GitHub. The core app is in the Python directory, and then I have other stuff in here that supports that. So it's all driven by Makefile, and what I did was build the Docker image. In the interest of time, so the Docker image is named Franklin Resume. So what's happening is there's 4 nodes in this Kubernetes cluster. So if I do kubectl get nodes, that'll show you here I have 4 Bs, but I also have something called Slurm. So Slurm is a scheduler, but I have it installed on all the nodes so I can do things like run a command across all the nodes. So for example, docker images grep. So you can see that even though Docker images didn't find the image on this node, when I run the same command across all 4 nodes, the ARM01 image, which is the one we want, is out there. So I don't have to do a pull. I should just be able to do a deploy, and that image will be used since it's already on the nodes. So let me go into the Kubernetes directory, and in here I have it broken down. So I tried this on GCP, also Google Cloud, but here I have it for my cluster. So long story short, I'm going to create a deployment and a service. So you can see right now the service isn't there. This is kind of a default. So it's pretty simple. You just kubectl apply or create, and then this file here contains the deployment, and it's that easy. So it's already available, so that's fast because I think the images were already downloaded, and I had run this earlier. So here's where the service will be. So if I just say kubectl apply from file, so I have a YAML file here also for the service. So now if I say kubectl get service, you can see that, yep, there's a service there. It's been up for 7 seconds, and it's exposed on port 5000. This IP here is the host I'm on. So you can see this page is up because latest is actually built for AMD 64-bit, so Intel AMD. This here is ARM. So the architecture I'm on is an ARM processor. So I had to rebuild the image and push that to my Docker Hub. So now if I say kubectl should be able to describe, let's see what this does. So this tells me that the application running in the container is running on node 2. Let's try this. Oh, I don't know why that didn't work. Oh, because I misspelled that word. There we go. So now we can see 2 instances are running on node 2 and 1 instance is running on node 3. So if everything worked, I should be able to now navigate in my browser, because the service exposes the IP and the port. And sure enough, it works. So that's my resume running in a container on three of these nodes. The service, I think, actually does some load balancing. Yeah, so it just load balances this app, exposes the external IP from the deployments, which are specified in this short piece of YAML. So very easy. The hardest part was waiting for it to rebuild the container with all the dependencies in ARM. The application has a lot of dependencies, Flask, Python stuff. So just to show, if I let's say I delete the service, now if I reload the page, she's dead. So that's it. That's how I run containers on my Raspberry Pi cluster, 4-node, 4B, 4 gig piece. Pretty cool.